Hello friends, today we will discuss about voltage follower. First we will discuss about what is a voltage follower and how we can construct a voltage follower using op amp. Finally we will discuss one application example. Voltage follower is the circuit in which the output voltage will be equal to the input voltage and the phase difference between the output and input will be 0, which means that the output will be exactly same as that of the input voltage as far as the magnitude and phase is concerned. The other names of voltage follower are unity gain amplifier, isolation amplifier and buffer. Now let us see the circuit diagram of voltage follower. The voltage follower using op amp is an application of non-inverting amplifier, which means that the input voltage Vi is given to the non-inverting input terminal and the inverting input terminal is connected to the output through zero feedback resistance. If you see the input resistance to this circuit as infinity and the feedback resistance is 0 and the output voltage is measured here. As I said, the input resistance Ri is equal to infinity and the feedback resistance Rf is equal to 0. We know that the gain of non-inverting amplifier, that is V out by Vi, is equal to 1 plus Rf by Ri. So in this circuit Rf is 0 and Ri is infinity. Substituting this 1 plus 0 by infinity, which is V out by Vi is equal to 1. This is the first relationship. Due to this fact, the amplifier is called as unity gain amplifier. There is a gain of the amplifier is 1. If you further use this expression, V out is equal to 1 into Vi, that is Vi, that is input voltage and output voltage are equal. Output is equal to input. This is the reason why we call this circuit as a voltage follower. The output voltage follows the input voltage. That is a concept. So I think it is very clear. I repeat once again, the application of operational amplifier in non-inverting amplifier mode is used here. Ri, input resistance is infinity because there is no resistance connected between the inverting input terminal and ground. Feedback resistance is 0. It is connected by a short circuit. Okay, so V out by Va is equal to 1 plus Rf by Ri. This is the gain formula for non-inverting amplifier. Substituting the resistance values, we get V out by Va is equal to 1. This is why we call it as a unity gain amplifier, or V out is equal to Vi. The output voltage follows the input, so we call it as a voltage follower. When there is no difference between the amplitude and phase of the input and output signal, you may have a question of why the voltage follower is required. To answer you, the advantages and uses of voltage follower are, the very basic thing is very high input impedance and very low output impedance. This is used to avoid loading effect. Let us discuss while discussing the example, application example. The application of voltage follower can be found in filter circuits, analog to digital converters and interfacing transducers, etc. To have more clear understanding, let us take one example of voltage divider. Everybody of us knows that voltage divider is used to split the voltage, DC voltage available into different voltage levels. For the sake of simplicity, let me take a simple voltage divider with R1 and R2 which are having equal value. Let us assume that 1 kilo ohm R1, 1 kilo ohm R2. The supply voltage as 10 volt. I want to tap the voltage from here and supply to a load of 1 kilo ohm. Okay, this is the load. First, let us find out the voltage available at this point. So V, let us term it as V out. V out is equal to V divided by R1 plus R2, that is equal into R2, that is equal to 10 divided by 1 into 10 power 3 plus 1 into 10 power 3 into 1 into 10 power 3. So V out is equal to 5 volt. V out is equal to 5 volt. Now when I connect a load of 1 kilo ohm between the ground and this expression will get changed. Let us see how it is getting changed. Now these two resistors are coming in parallel. So this circuit will be like this. The supply voltage 10 volt, 1 kilo ohm resistance, and here 1 kilo ohm, and here one more 1 kilo ohm comes in parallel. So what will happen is these two will come as a parallel combination. So this will be like this, 1K. Here it will become 0.5K. So if you make calculation and if you find out the voltage across here, V out, that is voltage across the load, it will be 2.5 volt. So this should be avoided. So in such cases, if you use a circuit like this, an op amp voltage follower in between, this will take 5 volt as a reference. I will mark the values here, 10 volt, 1K, here also 1K, load I am considering as 1K. In this case, the op amp will be drawing very less amount of current. As we have discussed, the input impedance of voltage follower is very high and the output impedance is very low. So the circuit will be exactly maintaining 5 volt regardless of the load value. It may be 1 kilo ohm or 2 kilo ohm. So this is one application of voltage follower. We have several such applications. Suppose if you have a transducer here which can be delivering very less amount of current, which cannot be directly connected to the subsequent circuit. So we will be going for voltage follower circuit to make sure that the loading effect is not made on the sensor. So thank you friends, thanks for watching.